Hey everybody, welcome back. Just because we don't have any customer work, because of the situation you're well aware of, doesn't mean we don't have things to do around here. In this video, what I'm going to do is we need to replace the bearings and the spindle on the milling machine. In particular, the lower bearing on that spindle is kind of crapped out, or at least it's getting real close. I don't know how to do it, but we're going to get into it because there's no instructions even in the manual for this thing, how to do it, and the exploded parts diagram, the parts view I should say, looks like some kindergarten class did some sort of a group project to draw it. So yeah. Anyway, we're going to get to that in a second, but first I have a new sponsor for the channel and I wanted to get to that, and so that'll be right now, and then we'll get into the video. So here's our message from our sponsor.
This episode brought to you by Insure-A-Shaft, where we make sure that you get the shaft on your homeowner's insurance. What does Insure-A-Shaft do? We work with Florida legislators to write laws that are more favorable to attorneys to sue insurance companies, and then we probably, maybe, likely get kickbacks, and then everybody makes a crap load of money, and it costs the homeowner in the state of Florida a shitload of money on their premiums. And it even drives the insurance companies out of the state, which doesn't make much sense, but then again, as long as we're making money, we could really give a shit. Sir, as a homeowner in the state of Florida, what do you think of Insure-A-Shaft?
Oh yeah, I love getting rammed up the backside with a 130%, 140% increase in my insurance premiums. Yeah, that's great.
Mr. Legislator, what do you think of Insure-A-Shaft?
That's a great question, Johnny. Being a state senator, representative, whatever the hell I am, it's just wonderful that being a lawyer as well can be so freaking profitable and enrich us so much. Just when we work with the Florida bar to essentially dominate and screw all these insurance companies, and then they get sued, and then our lawyer friends get money, and then we get money, and oh my god, it's just a great thing. So as a legislator, how does that pronounce? Legislator? Yeah, I just love Insure-A-Shaft.
Remember, in the state of Florida, the best way to get the shaft is with Insure-A-Shaft.
I think I made my point. Okay, so I pulled off the top cover and the vise, get some clearance. We can raise the head as necessary to make clearance for the spindle clearance. But the main problem here is I don't really know how to get this off. Now, I like to use service manuals and instructions and things like that because it usually simplifies things, but as I said in the intro, this is the parts breakdown diagram. Looks like it was done by Mrs. Nussbaum's kindergarten class as a group project. But you can see right there that DM4 is supposed to be a spindle. I think that DMB1 is a bearing. I don't know. But if you go up top to that DM7, that is this. Okay, that's the pulley, the step pulley. Then on top of it you have the DM6, or is that something like that? Yeah, not an 8. It's a 6. That's got to be the nut. So the nut's got to come off. What also gives us the hint is, you see there's a section that's different from the nut, so that thread's on, of course. It's probably stuck on there like, nobody's business. But we're going to get her off. So what I originally did was, I tried Dad's old chain wrench wrapped around here. I'm doing some tap. This is dumb. So the next question I have is, which way does this nut go? Is it a right hand thread or a left hand thread? So when I kind of try to figure that out, I use a little bit of logic. Now this thing is essentially set up to turn clockwise if you think about it, because most drills, unless you're using a left hand drill bit, are going to turn to the clockwise direction or to the right, for lack of a better description. Gigantor. And also mills, unless you have a special mill. So if you think about that, and it's going to the right, and the torque's being applied to put it to the right. If it had a left-hand thread, okay, left-hand thread would loosen to the right and tighten to the left. I would think that would tend to want to make the nut loosen. So I think this is a standard right-hand thread. So in other words, we turn it counterclockwise to release it or to loosen it. That's at least my thinking on it. So again, when you go back to this, you know the nut's got to come off, okay? You know it's got to come off. I'm not sure if this nut is the only thing that holds the preload on the bearing or not, or the bearings on the what do you call it, the spindle. But we're going to get this off. So what I did was I ran down to Tractor Supply and also Auto Parts and got some help, some tools. Let me show you what I got. I measured across the flats. It's 2.110, so it's just under 2 1/8. So I went and got a 2 1/8 socket. Unfortunately, it's a 12 point. They didn't have a 6. And it's okay. It's pretty tight, but it's not great. I think it'll be good enough for this. That's 3/4 inch drive, which I don't have, so I got a adapter diehard at Advanced Auto Parts. They're in the same, complex or shopping center, so it was kind of easy to do. So what I'm going to do is I'm going to get the Ugga Dugga gun out. We'll turn the air compressor up to infinity, and then get this thing hooked up and see if we can brr it off. Maybe we can, or maybe we can't. I don't know. So let's give her a shot. I got you in a good position so you can see the failure. I'm sure it'll probably not work. We're on reverse. So let's give her a shot. Now, you know what? I probably should have gloves on, but oh well. Ah, look at that. It's coming off. Would you believe it? The son of a gun worked. Because this thing is more rusty than a freaking car up in New York State. Pretty rusty. But the son of a gun worked. That's all I care about. Ugh. Now, how do you get this off? I'm wondering if this is pressed on. This is going to be a nightmare. I don't know. I don't know if it's keyed or what, but definitely it's got to come off of there. This got to be part of the spindle right there. Assembly. Let me think about it. Okay, so it's 3 months later. Not really. And I'm going to try to pull this with a puller. Unfortunately, I only have a 2-jaw. See if it works. What I made here was a little adapter to go inside the top of the spindle there where the pull rod, whatever that's called, the drawbar rather, goes through. Because I don't want to mess this up. And the way this puller sits, it would mess that up. So this is just a grade 8 bolt that I did a little counter bore on. So that tip will sit in there. Just a tip and just for a second. And it goes like this. I mean, it may just be stuck from... Oh, it's coming right up. Look at this. I mean, I'm really an idiot today. I don't know why anybody's watching this video right now, because the guy doing it's a moron. Oh, wait a minute. This ain't right. It's just pushing the spindle. Man, I need drugs. I think we got to push on Nat. Doy. So I gotta make something else now, so hang on. Alright, let's try this again. God, what a moron. So I made this little part out of it's an old top cap to a Suzuki fork. And just turned it down so it fits right in the top here. Nice little a shoulder rather. Not a counter bore. A shoulder. Now let's try it again. So what I'm going to do is I'm going to go right for it, and I'm going to put a socket on there with a 3/8 drive doodad and see what happens with it there. She's a 3/4? Yeah, 3/4. Now I know this has got to come off this way because I'm looking at that stupid drawing again, and there's some spindle adjustment nuts in here somewhere. The drawing shows 2 of them, which kind of makes sense. So this has got to come off, but I can't risk breaking it, so I'm just going to kind of... Maybe I should put it on tighten again, yeah. And then we'll see what happens. Oh, yep, here we go. Cool. Popped off like a taper. I don't know, but that worked. Yeah, no? Yeah. It's a tapered shaft on the top here. Okay. You hear that? Now, I don't know if that makes any difference, but I think what was dampening that was the weight of that pulley there. So this pulley's on a taper. Let's take a look at it up closer. It's kind of neat how they did it. This pulley's tripping on myself here. This pulley's on a tapered shaft, so it only goes down so far. Taper holds it in place. And like I said, it pulled off with the puller like it was on a taper. So that works out. And then you have a bearing cover here. I did see that on the drawing. So we'll take this off next with these 3 panhead screws. And then take a look at what's underneath there. But this is what I'm talking about. Yeah, now you could kind of hear that when you spun it with the pulley there, but I think, like I said just now, that the pulley was kind of dampening it. So, yeah, they shouldn't be like that. They're drier than a popcorn fart. So we're going to go ahead and get this out now and see how to get the rest of it out. Then I'm sure we'll have to crank the head up here at some point and get some clearance and drop the whole shaft down. I'm thinking that maybe these bearings are, I know the bearings are, I don't know. I'm assuming the bearings are pressed on from what I'm reading online. But I got a press and I got pullers. I'm not too worried about that. But I'm not sure how they adjust, because I don't really see any way for a nut to be. Well, I don't know. Let's get it apart and see. I'm kind of speculating without actually looking at the damn thing. The other thing I'm thinking here is, if we go up in the air with this and just release this spring, return spring. No, it couldn't go all the way down. There's got to be. I was thinking the whole thing would come out, but why would it? This is the quill. I mean, we don't need to take off the quill. We need to get the spindle out of the quill, which has got to happen because I can feel the bottom of the bearing here. So spindle is stationary, of course, and the quill moves within it, or in concert with it somehow. I don't know. That's what I was thinking. Well, we got to go up anyway, most likely, so we'll just do that now. We're working without any instructions, and obviously the guy doing the work is not too bright, so we'll have to just figure it out as we go along. Number 3 Phillips will work just fine. We have ways of making you come out if you do not want to. Trust me, we have ways. I hope the hell I don't have to take this whole head apart to do this. I don't know. I wonder if there's a... Ooh. You know what? I wonder if there's nothing behind here, and this is an opening behind here too. Yeah, it might be. Now that I think about it. Let's take this cover off, and maybe that's how you get in there and adjust a bearing preload or something through this little opening here. Can you see even what I'm doing? You can't even see what I'm doing. What I'm doing is, right here there's a cover for this that shows the different crap on it. If I hit that, it's hollow. So I bet you that cover will, show us an opening to get it some stuff in here, I bet. Here's a better shot of what I'm talking about here. So that's definitely hollow. When you go over to the edge, it's not. I think. It's probably a waste of time. I'm really good at wasting time. Apparently I'm really good at doing stupid things too. Aha! Aha! Oh, okay. Well, I see it, but I'm not going to show you. No, I'm just kidding. I'll show you. I'll show you what I'm looking at. Now I completely don't know what the hell I'm doing. No, that's not true. Well, it's sort of true. I had to force the light on, and you can see that what we have is 2 spindle nuts, or 2 slotted nuts, or pin nuts, whatever you want to call them. I like to call them spindle nuts, or like the kind you use lock nuts on the on your what's its face thingy, doodad handlebars and stuff like that. So clearly that is holding something in regards to bearing preload. So okay, so you know what? I get it now. That's your upper spindle bearing. That's your lower spindle bearing. And then this apparently is a bearing block just for this top shaft with the taper on it. I'm guessing there's probably more than one bearing in there. It's probably 2. One at the bottom of this and one at the top of it. And those most likely would be just regular roller bearings, and these guys should be tapered roller bearings. So we've got more than just 2 bearings to replace most likely, but we're going to have to get this apart first. So I kind of see how they did this now. think what I'm going to do is try to knock these. They're actually spanner nuts. Not spanner. Yeah, spanner nuts. Not spindle nuts, but spanners. Now, if I had known that, I would have done this before I loosen this sucker up. Alright, we have a solution to this. We'll get her with this. Safety squints. Engaged. Actually, it's tightening. It must be a left-hand thread. Yep. Well, there you go. So I'm thinking this whole inner spindle is going to come out when we loosen these up. You know, that loosens them up. They're left-hand thread. I got them all loosened up. They're free and to navigate. Oh, yeah, it is. See? There you go. All right, so it does come down that way. Yeah, we just need to give it a little persuasion. There we go. I figured it would, because if you got these two, what are they, spanner nuts in here, they're kind of squeezing the thing together against the bearing. So now I'm going to go ahead and tap, and we should be able to get this inner spindle out. Once that's out, I'm not sure how to get this out yet, but we can. Once we get this out, we can definitely drive the bearing races out. There's not going to be any problem at all, because I'm taking this spindle out of the question unless I had to. There's a clock spring inside here. This isn't just the only spring that recoils it or brings it back up. So, you know, I'm not going to do that if I don't have to. So, but now you can see we've got some vertical movement, and I'm not hitting on the top of it. I'm hitting on the little tool that I made before, which I'll keep doing. I'll just drift it down. Drift away. And then we should be able to just bring it right down through. And then take the spindle, inner spindle out. Well, it's got to go this way. There's just no other way it can go. It's got to go. The spline is splined up inside here. So essentially the spline that's on this shaft is splined internally here to the internal spline here. That drives it from the pulley through this, I guess you'd call it a counter spindle, first spindle, whatever. And that gives you your vertical movement while it's under power. Because otherwise, how would you do that? It's a slip fit in there. So this has got to come out that way. It's got to, because it slips in on top. Now it does not want to go any further. It's getting nasty with it. Nope. Okay. Well, let me get back to you on this. Alright, so while I'm banging on this thing, I noticed that this upper tapered shaft is starting to come up on its own just from the action of the Jackson. So I'm just going to tap this out. It's obviously just a press, not even a press fit, a slip fit. Yeah. All right. So here's your the upper assembly. These bearings aren't any good either. So you got one there and one there. We'll deal with that another time. So that's the tapered shaft. No worse for the wear. So there we go. All right, and there's a spacer between them. That's what this part is. So you got an upper and lower. So that works out. I figured there was, but now we got a little bit more access to figure out how in the hell this thing comes out, because I cannot, for the life of me, figure out how this damn. Will you stop it? Well, this damn thing will not go any further. Now we can get these nuts off now, all the way up with them. All right, so those are out of the way. That has got to go down. It has got to. I'm just not sure. Now we got some good room to really wail on this thing, though. So, nope. There it goes. There it goes. Okay. Yeah. All right. There it goes. It's just stuck. Look at this crap. I mean, all right. So there's the upper tapered roller bearing. And she's freaking chooched, as you can see. She's bad. So, hope I can get a number off of it. You can take me higher enough. We can swing the head around too, but I don't think we need to. This thing goes really high, actually. One thing nice about this mill, you can really get pretty big casting underneath it. Alright, so let's go to full zoom. There's our shaft You said shaft. There's our taper for the R8 collets. And the drawbar, of course, goes down the middle of it. This is our tool that worked out really well to keep this end from being damaged. Now, all we got to do is identify bearings. Well, actually, I got to knock the bottom one out first. Let's knock the bottom one out. We're going to knock the bottom out of her. But they're definitely shot. All right. Oh, will you stop it? I got to reach down in there, do a classic reach around with something and bang that lower bearing out. So let's go ahead and do that. The only thing holding this sucker in should be that seal. Okay. We'll do it the old-fashioned way and actually pry the seal out. I figured it would just come with it, but of course it won't. Come on, baby. Well, that's what happens when you folks take off and go to the bathroom. You miss all the good stuff. Now I got the lower bearing out. That's the seal. All I need is a number or size or both off of it. Bottom bearing. Are you seeing this? Bottom bearing. Seal. This one's not bad. The top one's no good. Definitely. This is the one I was able to dribble some oil into, but she's still pretty. I mean, she smells terrible. It smells like that ancient freaking grease that you get something that's made like if you're on a machine tool that was built like in the 40s. It smells like that. These are NSK bearings. This is the what I say, the lower bearing. It's a 3207J. So what is the top one? Oh, it's definitely bigger than the top one. So that makes sense. So that would mean that they're not the same. This is also, and this is the top one now, the NSK. And in case you're working on one of these, and it is a, oh, I don't know, 3026J, HR3026J. Yeah. So again, the tiny one's at the top and the big one is at the bottom. It always is. So, all right, now the last thing we got to do on this particular job before we source bearings and such is I got to drive the races out, which shouldn't be a problem. There's no race on the top here, as you saw, because we've got these two guys, which are going to end up having to get pressed off and back on with the press at a later time. I'm just going to order the bearings first. These are Koyos, and they are 6009Z. Now the Z means it's a metal cover, at least on one side of it. Yeah, bottom side is open. I think a ZZ is metal on both sides. So this is the Z. See, this grease is pretty much shot. Alright, so that lower race actually feels okay to a degree. There's two notches on the inside here that are just above the race, where the race seats. So for the majority of it, there's a shoulder, and there's essentially a cutaway 180 degrees apart. I can feel it. I can feel it! And what that's for is to run a drift down. Run a drift down or some sort of a puller. I think I can find something to go in there and tap these out with. Yeah, that's what they do on that. Now on the top one, there is no such provision, but there is enough of a lip where I don't think there'll be a problem to reach up through and grab that. Probably, I would imagine you could do either one. Probably do the top one first so we get a little bit more flexibility, because this hole is pretty big compared to that. And then we'll drive the bottom one out. But definitely the races have to go. Go. These are not press fit. These would be interference fits. There's a textbook definition for both of those. But an interference fit is usually about 1 or 2 thou. And a press fit's more than that. 3, 4 thou, 3 thou and up, that sort of thing. So, but the way these things are in and coming out, there's no freaking way that's a press fit. This is definitely an interference fit, which is what I kind of expect to see because of the way this is constructed. Otherwise, this thing would have to come completely apart and go into a press of some sort to get everything apart. I thought that race felt okay, but it sure as hell don't look okay. Let me show you what this looks like. So if you had any justification for changing your bearings out, that'd be it right there, kiddos. She's chooched. And because they provided these two little spots, I'm kind of wondering if this one's going to be a little harder to get out, and I don't even know if I have a piece long enough to do it. Okay, we finally got that lower race out. I mean, this sucker was a real pain in the ass to get out. I'm going to give you some better shots of that here in a second, but here's the problem, all right? Problem is that there is, I mentioned earlier that there's these little cutaways in there to help you drive the bearing out. The trouble is they are not, they don't provide clearance above the cutaways to get a tool down at an angle. So if you kind of follow me here, if you're angling a tool down from the top adrift, there's no clearance above those little notches. So, you know, the race is in like this, and then there you have the little areas. You can kind of see a little bit of grease there that was present in those particular areas on each side. But again, above them is the problem. Let me show you what I mean by that, and then I'll go over what I did to try to do it before I made that little puller tool. Actually, I modified a puller tool. I'll show you that too. Okay, so you can see that little relief cut there. Again, I'm looking at it from the bottom, so you can see that the relief is present at the bottom. This shoulder right there essentially is where the race bottoms up or out, as the case may be. But above it, you can see above it, we just don't have any angle, any clearance to bring a tool down on top of that. So that's why I had to use a puller from the bottom. So I just wanted to kind of show you what I was dealing with here. Alright, so I took this puller that I got at a yard sale a little while ago. I don't know, 6 months ago or so. And this thing was pinned with the jaws facing inward, in other words, to do an OD. So I just took the pins out, flipped them around. Then I had to grind some clearance so they would actually collapse inwards enough to get inside that bore and grab that race. Now luckily you can see that these two duckbill looking gizmos are a little bit angled back down on themselves, which worked out real well, so it wouldn't necessarily slip off. And I just took a piece of steel which I had laying around and drilled a little pilot hole, or a little hole, a divot really, for that tool to catch into so it wouldn't tend to walk around. But when I got down to this face here, I didn't realize that there wasn't a counter bore in there. When I got down to this face, naturally with the steel up against it, I can't go anymore. So then I just took a couple of blocks that I had laying around in my toolbox, these old machinist blocks, which are pretty much not as accurate as you expect them to be, and just put them up to give me a little space, and then pulled it out. When I got it to a certain point, I could get in there and kind of wrap it out. So that's what I ultimately did. Tapped it out with a drift. So once you get it to a certain point, you can get a drift in there. But at the, when she's up in there, there's just no stinking way to do it. So I'm going to go lay out the parts now, and we'll go over the bearing numbers. We'll see if they're available and how much they cost. Okay, let's talk bearings. I'm going to get my bearings locally at a place in Sarasota called Bearings Marketing. I always like to shop locally first. I'd have two sets of numbers here for at least the tapered rollers, because I did look online to see if I could get them. And I could, of course, but then the blue here is where I can get them locally. That's $22.83 for the top bearing, and then $28.42 for the bottom one. And this would be these bearings here. Now, as far as nomenclature goes, if you're searching for bearings like this, normally these are called, we would normally call them races and then the bearing, but you'll often find them referred to as a cone and a cup. So you can get cones and cups separately. Like on my lathe, you use the same bearing, I believe it is, for the front and the back, and a different cup, or vice versa, I can't remember which. So you can definitely source these individually, but when you order a bearing, like from Bearings Marketing or online, you're going to get the cup and the cone, or the race and the bearing. So again, I looked these up by number, gave him the NSK numbers, because the two of these tapereds are NSKs, And two that are on, this is a deep groove ball bearing, which is a 1Z, like I said, a single Z rather, which is one cover only. They have the ones with the two covers, you just pop one off, it's not a big deal. And then those are $25.77 a piece. And I don't know the brands of them, but they always carry really good bearings. They don't carry the junk. But this bearing here in particular, from Motion Industries online, is $102 a piece for these 6009Zs. So it depends on where you shop for them as to how much you're going to pay. That's pretty much the lesson here. I made a goof up on this before when I said it looks like there's some sort of a ring in there. That's actually the race. You can see it moving around. It looks different because there's a shoulder on this shaft, obviously. So the way these things go on is you take this spring clip off and then drive them off that way. This spacer is probably has a standard as far as how much play. It's very, very tight, close to the surface of each bearing. So what I'll do is I'll measure that with a feeler gauge before I disassemble this, and then just duplicate it when I put it back together. So this is the reference bearing. It'll go down with the closed end down, and then once that seats, put the spacer on, or whatever this is. I guess it's a spacer. Yeah, and then put the other bearing on until we achieve that clearance. So that's how I'll do that. So yeah, not very expensive at all. So two of those, one of those, and one of those. The seal he did not have in stock. The seal size is a 48 by 72 by 12. This is in metric, okay, millimeters. And I'll explain what these mean here. Very simple when you're speccing a seal out. First of all, you look at the seal and you can see the numbers on it, okay? Don't worry about that TC, that's manufacturing or what have you. Just the 3-digit characters. So 48, 72, 12. All right, it is a 48, right? Yes. What this means is this is the ID, internal dimension. So that the first number is this size. So in other words, the size that the shaft it was go on. You said shaft. 72 is the overall dimension of what it goes into. In other words, a bore or a housing. And then 12 is the height or the thickness this way. All right. So he only had a 4872-7, so or an 8 or something like that. So I don't want to use that. I'll go online and find this. But I'm going to get the bearings and so forth from him. And we'll take another quick look at the lower main spindle bearing race, which is just as crapped out, I think, as the, yeah. So this is just as bad as the upper one. So they definitely need to be changed. These don't sound very well, and we'll change those, like I said before, and get everything cleaned up. All right, that's it. Yeah, got it done to the point that I'm getting it done today. Wasn't too terrible of a job ultimately once I figured out what I was doing. I told you I didn't know what I was doing right off the bat. Had to hunt and peck through it. Hunting your pecker is always fun, especially on a job like this. Okay, so it's always good, guys, to go to these yard sales and garage sales and things like that, estate sales around your neighborhood, and see if you can find crap like this, because this really saved the day on this job. As I showed you earlier with the dangly bit video, I could not get from the top down into that little spot to drive out that race or that cup. All right, so I took this, which I got I don't know 6 months ago or so, and modified it, and it worked. It's difficult to work with because it's not exactly the tool, but it worked. So I guess it is the tool then. If it works, it's the tool. So yeah, I think I paid $5 for that one and another one, and then that big sucker right there that I used when I pulled the pulley off earlier. So this is the stuff you get locally around your neighborhood, and then put in your toolbox, and you'll be surprised when you need it. And I needed it today, so that worked out real well. So yeah, we'll I'm not going to film putting it back together because you don't need to see that. You'll see this in upcoming work that I do, even if it's not customer work. I'm going to be using the mill. There's no question about it, making shit and stuff. So you'll see it. And we'll run the bearings in and get them adjusted up, and then it'll be fine. But they definitely need to be replaced. What caused that? It's definitely not usage as far as hours. This unit doesn't have a whole lot of hours on it. I could tell that. What it was sitting. It was sitting for a long, long time. That's why you get those lines in the cups or the races. because it gets a little moisture, corrosion, changes in temperature, and those things just beat the hell out of themselves once it starts spinning again, because of those irregularities that are now etched into the race. So they just beat themselves up, and that's what the problem was at this point. You can't save them, you got to replace them. I'll pick up the bearings on Monday. I'm not going to do it today, it's Friday. So I'm going to go ahead and clean up and take the rest of the day off. I hope you guys learned something from this video, got something out of it. The next job is going to be on the Magna. I'll be filming some carburetor work. So we'll take the carbs out, I'll put them on the bench, and we'll do some work on them because it's kind of running like shit, and I don't like that. So thanks for watching, and we'll catch you on the next video.